Hello, welcome to my channel. Today we have Leetcode 269 Alien Dictionary. And this question is rated as hard, but it's really helpful for learning the algorithm. Let's take a look at this question. So there's a new alien language that uses English alphabet. However, the order among the letter is unknown to you. So basically it's saying that English alphabet will have A to Z, and A is smallest and Z is biggest. So that's the alphabet order. But in this alien language, it had the same root but different order. So what's that mean is we can take a look at the example 1. So we compare the first one and second one, and you see the first two is the same. So yeah, it's hard to tell which one's faster, which one's smaller. Then you compare T and F. That means T is go earlier than F. So now we look at W and E right here. Compare these two. You see the W go earlier than the E. So let's mark it down. And E go faster than E. Yeah, the same. So now we look at the different one, which is R and T right here. So it say R is earlier than T. So R is earlier than T. So this is a clue that we find by comparing one by one. Now we compare this and this. So we see R is bigger than E. So E go faster, go earlier than R. So that's what we have in here. So now, how do we know the order for this one? So only the W doesn't have any in degree. So any of the other one have in degree, like R, the in degree is E. What's the in degree mean? If T is smaller than F, then F will have one in degree. So only W doesn't have in degree. That means W should be the earliest one. So now we have W go first. So now we know E's go later. We put E right here. And what's E? We have R go after E. So just say we have R after E. And look at R. Then we see T. Look at T, we have F. And this is the order that fulfill all this condition right here. And it cover every character in this array. So that means this is the right order. And you see this output right here. And we make this as a string. Then we output this. That's how it is for this question. But what we need is we need something to store this information first. Let's take a look at the drawing. So now we have this right here. What we need is we have a hash map that take in, look at this one first. We loop through the whole entire words and pick every character in here to put it in the map. So we have W in the map, and we'll put an empty set right here to store anything behind that, behind the W right here. So we have R for sure. We get every character in this map as a key. So we have T. This is T right here. And this already covered. WR is covered. And we have F. F's done. We have E. E's R is gone. E has it. T. We have T. T. And I think we cover everything in here. So this is all the key for the hash map. We give it all empty set right here. We also, during this time, we also need to loop through. We have something called in degree table. In degree table, I'll just say in table. to capture, for example, we have 26 index. 0 will be A and 2 C. So in this case, we have, for example, we have F. So we go to F, the location of F increased by 1, E increased by 1, T increased by 1, R increased by 1. So that's all the comparison, and we get all this table right here. This is two things we need to have before we move forward later on. So now let's build this one right now. Let's build this two things first. Let's see how we do later. Let's erase this one. And now we have it. Let's make this first, because this question is pretty long, so I will try to make it character. We have set character as a map. So we have the map right here. And also we have an in degree. In degree 6 index. First thing we need to do is build the table that we have, which is the hash map. We go build map, and we will call a function build grid build map. This is how we build it. Later, after we build it, we will do the DFS to get the right order. So DF and the DFS will return the correct order. So we just basically return the DFS in here. So for this build map, we will need to put in words and map and the in degree. So let's take a look at this one right here, this step right here first. Public void, I think it's void, yeah, void. We call build map that take in string array of words, also map character, set character, which is called map. We also have in degrees called in degree. This is the function, and it doesn't do anything but just put everything. We try to build this map and also build the in degree in here for this function. So first thing, we have double loop. What we do is we loop through the whole entire words to capture every individual character. Like what we said, we capture the individual character. Let me draw one more time. To build those, put it as a key, so we can put the later character for that key. Okay, that's what we do now. So we loop through the whole entire words. And another for loop for every character C in that words. We will put that in the map, and map.put if absent. So that if that's absent, then we put it in there. So what we need to put in will we have C, which is that character, every individual character. And we will put the empty hash set in there as the value. So now we have an empty template right here. So next thing we're gonna do is come here. Remember we have the like T to F and W to R, that comparison. How do we come up this comparison is by loop through this one by one. And then we can start with having a for loop start with int equal to 1. And then I loop to all the way to the end. So we compare. So we have a string first equal to word I minus 1. So we started right here as index 1, and we need to capture the first, which is I minus 1, and I is the second. So we have first and second. Then here we need to have edge case. I'm not going to talk about it now. I will add it later. So I just have encountered this problem by submitting yesterday. So we talk about that later, but I'll come back later. So for in j equal to 0 and j is less than first dot length, which means we look through the whole all the character in here to find which is the first index that they have the different character. If they have the same character like this, W and W, R and R, we can't tell which one's faster, which one's smaller and bigger, until we find the different one, like T and F. So now we know T is earlier. That time we J plus 1. So we get that key equal to the beginning one, which is the first dot chart at J. So in here, the key will be T and the value will be F. That's how we define. So now key is T, F is value. Now we know we have to check if key is not equal to value, then we do things. Otherwise, we pass. Only when it's different, then we do. We have the relationship in here. So if it's different, and also we need to check the map of that key doesn't already contain the value already. So we get key contain value, then we do things. For example, if T already have F, now after this T will have F. In here, the F will put it right here for T. So for example, this is T. We put F in this set. We check if this set already has contained the F or not. Because we need to check that, because we need to also increment the in degree for F. In this case, put F in this, and we also increment F in degree by 1. So that's why we have this condition check in here. So after checking this, let me see, I'm going too far. After checking this, yeah, we'll have the, so now we make sure that the value is not in here, then we check in table in degree of this value should increment it by 1 first. Next thing, yeah, since it's not there, then we have to add it. Map.get key.add value in there. So after this, then we should stop comparing, even though they have more later on. That's the only comparison that we can do. So we break out this loop. That's the first connection we find from the first place. And we continue doing that for this two, and we put all this relationship in the map and the in degree. This is this function right here for building the grid. Let me double check if there's anything missing right here. So yeah, I think that should be it. Then we can close this one. We just leave it right here. So now we know this is done. So we cancel this out. So this is done. Now we come to the DFS right here. We will have DFS. We will return a string because we are getting this information here to find the solution string. So let's stop for a while and then I will draw again. Okay. So now we have this two table that we just built. So how do we find the string? So the first thing, we will have a string builder, but that's too detailed. But the idea is we have a queue right here. So it's queue. Because we know already, we have all the keys here. This is all the key that we have. We look through this key and also look at this table. W, E, R, T, because they have their in degree, but only the W in degree is 0, because no one give them an in degree. Since this is 0, that means this is our starting point. So we put that inside this queue, then we start with that. We just mean, and then we pop out this W and put it to the string builder. So now string builder right here. And already start with W because it's the earliest one. And now we have W, and then we come to this map, we search W to see what is the later part, what's after W, right? And we see, we check every value and deduct that in degree. We check, oh, we have 1 and 2. We come to this one, deducts 1 in degree. If that in degree, after you deduct it by 1, because you take out 1, if this is 0, then we put that character in the queue. If it's not, then forget it. And then we come to the second one and also deduct the in degree. That's how we keep the in degree. Now we get this one and deduct it 1 and also check if the in degree for this character is 0 or not. If any of the character after deducted by 1 is 0, then we put it to here to operate it until we find all the order, and we put, every time we put out, pull 1 from the queue, and that's the next available to put it to maybe E, for example, yeah. For this string builder, we just keep building it, keep building it. At the end, we have this string in order. So what's that mean? That means really in order. But there's one thing they need to compare is the output and the size of this, how many characters in here. If the size doesn't match, then we have a condition here, like here. Sorry for making this mess here. If there's no solution, and we return the double quote, okay. And that's the idea in here. Okay, I will keep this right here. Sorry for making all the mess. And now we try to build this DFS right here. DFS, we have, all we need is the map, character set, character, and map. We also need an in degree. Cool. In degree. So we start with a string builder. SB is equal to new string builder. And also we need a queue that will keep track of every character. Queue equal to okay, queue brain freeze. Okay, we have a linked list right here. Okay, we have two. What do we need? Give me a second thinking. We loop through this whole entire map to see which one have zero in degree. Then we put it to the queue. So we have character C. We check map.get set get key. Check all the keys. We check in if in degree of this C minus A, that's the location of that, is equal to 0, then we put it to the queue. Queue.offer C, and then SB, surely append C, which is here. We put W to the SB already. So now we put every 0 in degree to the queue. Now we have to make a while loop to loop through the queue. If queue is not empty, we always do that for DFS, and we keep this, keep track of this queue and keep looping, having a while loop here. Then we know we need to pull one of the character from the queue equal to queue.pull. So now we know, just in this example, we have a W right here. So what we do, we loop through every character in this hash map. We have character called next character. Every character after W. That in map.get C is the character. We loop through that, and every time we see one, and we decrease one in degree from the in degree table. So in degree table of that next C, we shouldn't use here. We should use lowercase. Next, C minus article. We deduct it by 1 and check if in degree next C minus 8, that location, if it's 0, in degree is 0, that means nothing after that next C. So we put Q dot offer that next C. We put that in the queue. We also XP append that next C. So we capture the next C and we put it to the SB. So now we almost here. I mean, we already built the SB by getting these two functions. Let's quickly end this function by checking. We already captured the SB in the right order. At last, we check is sb.length equal to map.size or not. So if they're not the same, I mean, if they're the same, then we return sb.toString. If it's not the same, then it's no solution right there. Then we'll return this empty string. Oh, sorry. So now I'm just running this one. So this two function already done. Let's run this one. Oh, I forgot to put things in there. We also need to put the map and in degree in this one. This one already canceled it. So this is an empty data structure we built, and then this one function, another function. Okay, run one more time. Word doesn't have. Okay. Oh, sorry for my typo. It's a lot. Maybe I'm typing too fast. Get key. See, number 39. Get key set. I think it's not key set, right? Should be key set. Oh, Q is not this Q. Yeah, it changes. All right. See if there's anything wrong here. Okay, cool. So we pass example right here. So this example should be passing. And I now have this one right here. As there's edge cases, they updated, it doesn't pass my. So we have runtime error right here. Interesting. Yeah, because this case. So I erase this drawing right now. Because usually when we have like we have ABC order, like the alphabet order, usually AB always come before ABC. It doesn't have this order right here. Is anything happen like this? This is the edge case. Then we return that called no solution. Then we also need to return the double empty string right here. And it doesn't work in this case. So now let's add this edge case in here. We will see if first length bigger than second length, which is in here, right here, is bigger, and first start with second. For that case, we will empty this map, clear this map, and do nothing for that map. After clearing, return, and then just stop this function right away. So it wouldn't go down. And that's it for this. If they receive an empty map for DFS, it will return empty because it's nothing to do, for them to process. So that's it for this case. Let me pass one more time. And that's it. And it passed. If you want to know more and then practice more, and there's one question really similar to this question, and I will put the link, which is called course schedule, and I will put the link in the description. I will strongly recommend you to go over that one again, because its concept is really similar. So I will, if you have any question, please comment below, and I will see you in the next video. Thank you so much. Bye-bye.